Imagine you're sitting in a classroom, and your statistics professor starts talking about a theorem called the Central Limit Theorem. You're half asleep, and you start to doze off. Suddenly, the professor starts talking about how the theorem can help you win at the casino. Now you're interested. Well, today we're going to talk about the Central Limit Theorem, and how it can help you in real-life situations. The Central Limit Theorem is a statistical concept that says that as the sample size increases, the distribution of the sample means approaches a normal distribution, regardless of the shape of the original population distribution. Simply put, it means that if you take multiple random samples of a population, the means of those samples will be distributed normally, even if the population itself is not normally distributed. A real-life example of the Central Limit Theorem is the distribution of heights in a population. Although the heights of individuals in a population may not be normally distributed, the mean height of multiple samples of the population will be distributed normally. The Central Limit Theorem was first introduced by the French mathematician Abraham de Moivre in the 18th century. De Moivre was studying the binomial distribution, which describes the probability of getting a certain number of successes in a fixed number of trials. De Moivre observed that as the number of trials increased, the binomial distribution started to resemble a normal distribution. The Central Limit Theorem is applicable in a wide range of fields, including finance, engineering, psychology, and biology. For example, in finance, it is used to model stock returns and to calculate the probability of extreme events. In engineering, it is used to analyze the strength of materials and the behavior of systems under different conditions. In psychology, it is used to study cognitive performance and to analyze the results of psychological experiments. In biology, it is used to analyze DNA sequences and to study the behavior of biological systems. The Central Limit Theorem is a powerful tool for statisticians because it allows them to make inferences about a population based on a sample. For example, if we want to estimate the average height of all people in a certain country, we can take a sample of heights and use the Central Limit Theorem to calculate a confidence interval for the population mean. This can help us make decisions or draw conclusions based on limited information. The Central Limit Theorem has several key concepts, including sample size, mean, and standard deviation. The larger the sample size, the closer the distribution of sample means will be to a normal distribution. The mean of the sample means will be the same as the population mean, and the standard deviation of the sample means, also known as the standard error, will decrease as the sample size increases. A real-life example of the Central Limit Theorem in action is the accuracy of polls. Pollsters take a sample of voters and use the Central Limit Theorem to estimate the percentage of voters who will support a certain candidate, with a certain degree of confidence. The Central Limit Theorem is a fundamental concept in statistics that has many practical applications in various fields. By understanding the basic concepts of the Central Limit Theorem, we can use statistics to gain insights and make informed decisions in our personal and professional lives. Whether we are analyzing stock returns, studying cognitive performance, or estimating the height of a population, the Central Limit Theorem can help us to better understand the behavior of the world around. If you enjoyed this video on the Central Limit Theorem, please consider subscribing to our channel for more great content. And if you found the information useful, please share the video with your friends and colleagues to help spread awareness about this important statistical concept. Thank you for watching.